All right, let's clean up our notes from 633 on derivatives of inverses. The first thing we want to double check that we have in our notes is that we understand that f of g of x, when that equals x, then we have an inverse. Because when we put g into f, f undoes whatever g did and brings us back to just x. Then what we did in class is we derived the whole thing. So on the left side, we'll derive and we'll get f prime of g of x times the chain rule of the inside. The derivative of the inside would be g prime of x equals the derivative of x is 1. Then when we divided and got g by itself, g prime by itself, we get g prime of x equals 1 over f prime of g of x. Now in class we talked about the other way to write it with just f and f inverse, but I'll leave it as g prime equals 1 over f inverse for this example. So where is this useful? This is useful a lot like what we did with implicit differentiation. If we have a function, say f of x equals 1/4 x cubed plus x minus 1, and we can't just switch x's and y's and get the new y by itself. The reason we wouldn't, same thing with implicit differentiation, is that we've got an x cubed and an x. We'd never be able to factor it out. So the only way to find, and again, let's do an example of f inverse prime of 3 would be to use the formula. The thing to remember is that if we want to find f inverse prime of 3, we can also see that written with the notation of g prime of 3 if we're using this formula right here. We want to find the derivative of the inverse at a point. So that's how we'd like it to be written. So if we plug that into our formula, g prime of 3 will be 1 over f prime of g of 3. So the first thing we're looking at is we'd like to know what is g of 3 in order to run through this. To find what g of 3 is, we need to know what x in f gives me 3. So we can set 1/4 x cubed plus x minus 1 equal to 3. I'm going to use my table in my calculator, and I'm going to find that f of 2 equals 3. If their inverse is an f of 2 equals 3, then g of 3 equals 2. So that allows me to put g of 3 is 2 right here. So if g of 3 is 2, we put the 2 into f prime. So the last thing we have to do is find the derivative of f. So f prime of x is going to be 1 over 4 times 3. So we'll call it 3/4 x squared plus 1. And then if we put our f prime of 2 in there, x2 squared is 4 times 3/4 is 3 plus 1 is 4. So f prime of 2 is 4. So g prime of 3 finally will be 1 over 4. So using our new inverse derivative, we can find the slope of an inverse without having to find the derivative of the inverse or even have to find the inverse itself.